Hello everyone, this is Mr. 13 Things. I'm picking this video up without a lot of great explanation, as we're going to more or less start clean again. But I want to point out in the previous video I talked about setting up the color. You notice my background's a little off black so we can differentiate from the master Sal Khan and what he does. You might want to differentiate different colors for different concepts with students. I'm letting you know I'm capturing at 1280 by 720 using Camtasia. Cam Studio is a similar software, but it's free. And we're talking right now about how to do transformations on a simple triangle, which is comprised of edges, which are comprised of points. So I can now kind of go back and start from the theory of what we're going to be doing with transformations. And if you are aware of a curriculum called Everyday Math, and I think many other good maths, they will start students dealing with things like translate, rotate, and reflect probably every year, starting in second grade and third and fourth, etc. And these are important concepts. I give you no doubt that understanding how shapes move. What they don't necessarily let students know is that's also what's going on when they're playing their Xbox 360 or their Game Boy or Nintendo or even moving paper dolls around a page. They're doing simple transformations. And those transformations can be done mathematically if you just get involved in very simple, basic vector mathematics. All right, so let's look at what a triangle. I'm going to try to do this color now. I'm going to keep the basic green color for that point there. And I'll try to now, I guess, pick a blue color for the edges, right? This edge there. But now for the points, I'm going to try to colorize. We'll see if I can do that. I'm going to put a point here that's red, right? And I'm going to talk about how we describe that point. Mathematically, we remember that point was probably something, if we looked at it in the typical ordered pair, -1, comma, -1, though in reality we realize it has a z-coordinate as well. So how do we write that? Well, we would write that point like this, mathematically. A simple vector, a column vector with a -1, a -1, and then we have to have a 0 there to describe the z. And later on, you're going to see, now I'm going to see how I can or cannot manage this. I'm going to try to go back here. You're going to go ahead and put a 1 down here because that's really just a filler number. So that's how you describe that point there. That's how that point is mathematically written. It is a column vector, right? And so if you teach students right away to do dual accounting, they can very quickly make this transition, especially if you're then showing them how cool it works when you're playing around with the stuff on your Xbox. So let me go and see if I can find another color here, which it seems to be a reasonably good job doing it. I'm going to go ahead and pick orange there. I'm going to put an orange point there. See, it jumped around. And that point then looks like this. It's a separate column vector. And just like that one was -1, this one is 1 and -1. And of course, it has that third coordinate. And if in fact it's going to throw students to use 3 coordinates when you do this notation, then just don't do it. Call that 1 in the x, -1 in the y, again the 0, and let's see if I can, oh, I can do that. I can pick up the color there. Very nice. And now back to pen, and then, so that's pretty sweet. What I showed you, for those of you who are learning how to run this program, I could eyedrop the color, and I've got that second point described now. Remember, the orange are the actual mathematics of the point, and this down here is just a scale factor that we're going to use when we try to do mathematical transformations. All right, so we're going to do the third point now, and I guess I can choose a reddish one here, and I can go to there and choose a reddish one there, and I'm now going to put that third point there, and I don't even know if these are actually to scale, but let's assume that this is 0 in the x and 1 in the y, and that point then is going to look like this when you write it out, right? It's going to be 0 in the x, 1 in the y, 0 in the z. We can use that handy dandy little color sucker here and then give it a 1 here as well. I guess you can. Let's see, maybe you can. I tried to use the handy dandy little sucker. I was so excited to have that down. Looks like I can do it now. And I'm going to tell it now a pen, and I'm going to do it 1. Okay. So what we have described here is actually not the triangle. We've only described the 3 points, and 3 points, in fact, will either describe a line or a triangle, one or the other. Those are your 2 choices, or if they're the same point, there's 1 point. So 3 points will either describe a line, a 3D line, or a 3D triangle. Now, what we know later is basically if we go ahead giving these point numbers, I can call that point 0, point 1, and point 2. Noticing now, we might also introduce students that sometimes they begin counting at 0, sometimes 1. I'll defer to you on that, but if you are going to be dealing in computer programs at 4th grade, one of the important things students can grasp is sometimes you start at 0 and sometimes you start at 1. Most of the time in computers you start in 0. Some of the times you start in 1. So that's kind of an important concept. Students can arrange these things in their brain. They're playing Xbox, by golly, and shooting zombies. So if you think about this, the only other data structure I need to do to explain that this is a triangle, it's really implied on this, but I could also then eventually give you something like, see if I can use the same color. I could call that line 1, and call that line 2, and call that line 3, and over here in a separate, set of data, I could say that line 1 is something that goes from point 0 to point 1, and I could actually give it a scale if I wanted. And line 2 is something that goes from point 1 to point 2, and line 3 is something that goes from point 2 to point 0. And that defines then each of these lines. And then, in fact, I could go further than that and tell you that polygon, or the triangle here, is something that is defined by line 0. I'm sorry, we call that line 1, line 2, and line 3. And so what you end up is you end up with a lot of data that are stacked. I put this there. Most of this and this you don't necessarily need students to grasp. As long as they can grasp at any time you're moving a 3D shape, you're moving all of its individual points. The fact that you can notate points that are 2-dimensional points in a 3-dimensional structure because everything has a 3rd dimension. And then slap a number here on the bottom. This gives them the ability to do something that they've been doing in their Xbox forever, and that is apply transformations. Now, I will defer to Sal Khan and the Khan Academy and those incredible wizards out there to get you talking about the mathematics of what makes transformations work. But as I was watching some of the great linear algebra stuff out on Khan Academy, when they were presenting the linear algebra stuff, which is how you deal with things like vectors, and we'll talk about matrices in a little bit, they talked about transformations last. They talked about other ways that you use matrices, and they talked about transformations. I'm going to tell you, it is my general premise that this transformation stuff should be taught first to students. Before you teach them matrices for solving simultaneous equations, you should teach them what you've been teaching them well, I would say, in terms of geometric transformations and what they've been learning in their Xbox 360, their PSPs, all this stuff. And so at core, what's going on is just manipulation of a lot of different points. So when we come back, I'm going to leave some of this stuff up so I don't have to redraw it. I guess I can try to show you how that works on here as well. And then come back and show you the next step of once you get students to do dual accounting or dual notation, how you can show them the effect of what a transformation and what a matrix is, tying it to this important concept of the rule of multiplicative identity. Thanks for listening.